Drop my pen. Okay, we're about to take kind of a lot of our big ideas. So Planck and Einstein and Bohr and mush them all together. But I was just looking at this note set and I feel like it's going to make more sense maybe if we start on the second block of notes and then we'll go back up to that first little Bohr's model chunk. So just jump down to the very bottom where it says ground state and the excited state of the atom. Okay, so over here, I just have already sketched this because I'm really bad at drawing and talking, so maybe you want to sketch it while I'm yapping at you. This is a Bohr model, right? And we've got just a couple electrons drawn. There would probably be more. And there's a couple different terms we want to be aware of, okay? So one of these is called the ground state. And so we're going to fill this in over on the left here. It says the atom exists at its, it is, oh, that's the wrong it's. It's not it is. No, there should be no apostrophe. I'm so sorry. The atom exists at its lowest energy level, and when it's there, we call this the ground state. Also, that line is in the wrong spot. Oh man, things are falling apart. Okay, ground state, lowest energy level for an electron. Now, one thing I want to get out of your mind right away is that doesn't have to be the lowest overall energy level. Different electrons live in different regions, and so for this electron, we're saying its ground state, it happens to be the second ring, okay? And eventually we'll get rid of these rings and replace them with orbitals, but it doesn't have to be the lowest in the atom, but it's the lowest for that electron. Hopefully that makes sense, okay? But electrons can absorb energy in the form of light or heat or something like that. And so imagine this is our little energy, and when it does that, an atom, if it gets enough energy, an electron, if it gets enough energy, can jump up 1 or 2 or 3 or however many energy states, and it enters what we call the excited state. That's the scientific term for it. You could think of it as energized state. Maybe that would make more sense to you. Okay, so like I just said, we'll write it out here. When enough energy is present, and that's key, enough, quanta, when enough energy is present, the atom will absorb that energy and move a number of energy levels equivalent to the amount of energy absorbed. Okay, so if it absorbs enough to jump 1 energy level, it jumps 1. If it absorbs a lot, then it can jump up maybe 3 or something like that. Okay, well, when it jumps up, as we just said, we call that the excited state. Let's just slide down here a little bit more in the notes and do this part here about absorption and emission, and then we'll jump back to the beginning. So far, I've really failed at making this particular and maybe all of the notes set. Okay, so as we said, the excited state, the atoms have already absorbed their energy and they've moved to a higher energy state. Okay, so we just said this, we're just kind of formalizing it so we can put it all together here. That's the excited state. Now, when they're at that excited state, eventually, nature, like we like to get to our lowest energy point. Nature tends towards stability. We want to get to the lowest energy. We'll talk about that a ton when we talk about chemical bonding. And so eventually that electron's going to want to relax back down. And to do that, then it's going to have to emit energy level, or it's going to have to emit energy equal to whatever it just absorbed. So if it absorbed 2 photons of whatever, it's going to have to emit 2 to get back to that ground state. Now, it might emit 1 and then 1 more. That would be fine, but it needs to get enough to go back to where it started. And so we're going to just say for ease today, we're going to say it's going to emit energy at a frequency equivalent to the energy absorbed. And once it does that, you could do it in 1 step or 2 or 3, then it will return to the ground state. Okay, so let's just sketch ourselves 2 more quick Bohr models here. I'm going to pause and do that. Voila, it's like a cooking show. And there they are. We've got 2 atoms here. One I'm going to show an electron absorbing energy. So let's just say that it's here. We'll have our little energy burst come in. Shoom! That is going to cause it to go to a higher energy level. Okay, so we want to get that in our head. An electron absorbs energy, it's going to jump up. Okay, it's going to jump up to a higher energy state. Think of it like climbing rungs of a ladder. If you absorb energy, you go higher on the ladder. You'd be higher up on the rings in the atom. Where an atom at some point, gotta stop using the wrong word, an electron at some point can release energy. This is the energy leaving it, and then that will cause it to fall back down to a lower energy state. So sometimes we can actually see this in the form of light, which is we're going to talk about here in just a second, depending on what wavelength it is. It might be heat if it's in like the infrared. It could be UV, which we can't see. But if this jump happens to have an energy that matches with the visible spectrum, we can actually see that. And as that falls down, so emitting energy is going to a lower energy state.